information about how Ghana came about. Is that okay? Yes. So if you want the history of Ghana, if you are researching on the history of Ghana, just type the information there. Let me look at, let's say, Dr. Kwame Nkrumah. Do you see that? So we have partial matches, isn't it? Yes. Dr. Kwame Nkrumah. So let me add Osadifo in it. Osadifo. So it's still giving me partial matches, isn't it? Okay. So let me see life history. These are some partial matches it is giving me. Is that okay? Yes, these are some life history theory. Let me see what it's giving me. Okay, let me see. President of the Republic of Ghana. Republic of Ghana. It's not giving me that. Okay, so let me see. Let me delete this. Enter. So you see, the name Nkrumah, the name Nkrumah is already there. You see that? So I just wanted the name Nkrumah. So Kwame Nkrumah, have you seen that? Yes. So if you type Nkrumah now, you see Kwame Nkrumah, 21st September 1909 to 27th April 1972, was the leader of Ghana and his predecessor state, the Gold Coast, from 1951 to 1966. So you see information about Nkrumah has been displayed here. Do you see that? So that is how you use the offline Wikipedia tool. So with the help of this tool, you just need to type the title of your information on the address bar or the search bar, and then you get the information coming. Is that okay? Yes. Because it is pre-programmed, the information has to be accurate. So you see that when I was typing different information that are not related or that is not on it, it is not giving me the exact results. But you see that when you are able to get the accurate information, for instance, like I did with the solar system, you saw that it gave me the information that we needed, isn't it? Yes. So that is how the program is designed. All right. So enough of the offline Wikipedia program. Let's go to the digital library system, which is over here. We're just showing to the other batch how the digital library system works. Is that okay? This one, we are aware most of you complain about math being difficult, isn't it? Yes, with this program, it has made math simple. Is that okay? You don't even need a teacher to tell you what they are doing here. Is that okay? It's self-explanatory. Such that at the end of the day, you understand what is going on and you can see the videos for yourself, how it is being worked. Is that okay? Yes. So let's, begin all over. So let me see. So we're just dealing with ratios. Okay?
Assuming that this is okay under fair use, because
so you are watching
for a math problem. But I want you to watch this video, and then I'll ask you a question about it. So you see, it's exciting in any language that you might watch it. But my question to you is, how fast was Usain Bolt going? What was his average speed when he ran that 100 meters right there? And I encourage you to watch the video as many times as you need to do it. And now I'll give you a little bit of time to think about it, and then we will solve it. So we needed to figure out how fast was Usain Bolt going over the 100 meters. So we're really thinking about, in the case of this problem, average speed or average rate. And you might already be familiar with the notion that distance is equal to rate or speed, I'll just write rate, times time. And I could write times like that. Once we start doing algebra, the traditional multiplication symbol can seem very confusing because it looks just like the variable x. So instead, I will write times like this. So distance is equal to rate times time. And hopefully this makes some intuitive sense for you. If your rate or your speed were 10 meters per second, just as an example, that's not necessarily how fast he went, but if you went 10 meters per second, and if you were to do that for 2 seconds, then it should hopefully make intuitive sense that you went 20 meters. You went 10 meters per second for 2 seconds. And it also works out mathematically. 10 times 2 is equal to 20. And then you have seconds in the denominator and seconds up here in the numerator. I just wrote seconds here with an S. I wrote it out there. But they also cancel out, and you're just left with the units of meters. So you're just left with 20 meters. So hopefully this makes intuitive sense. With that out of the way, let's actually think about the problem at hand. What information do we actually have? So we have the distance. So what is the distance in the video we just did? And I'll give you a second or two to think about it. Well, this race was 100 meters, so the distance was 100 meters. Now, what else do we know? Do we know, well, we're trying to figure out the rate, that's what we're going to figure out. What else do we know out of this expression, out of this equation right over here? Well, do we know the time? Do we know the time? What was the time that it took Usain Bolt to run the 100 meters? And I'll give you another few seconds to think about that. Well, luckily, they were timing the whole thing. And it's a world record.
So now you know that time and you know the
seconds is how long it took Usain Bolt to run the 100 meters. It was 9.58 seconds, and I'll just write S for seconds. So given this information here, what you need to attempt to do is now give us our rate in terms of meters per second. I want you to think if you can figure out the rate in terms of meters per second. We know the distance and we know the time. Well, let's substitute these values into this equation right over here. We know the distance is 100 meters. The distance is 100 meters. And it's equal to, we don't know the rate, so I'll just write rate right over here. And let me write it that same color. It's equal to rate times, and what's the time? We do know the time. It's 9.58 seconds. 9.58 seconds. So this time, and we care about rate.
Let me just So this time you can see that from here the distance is equal to rate times time, isn't it? And you know the distance to be 100 meters. You know the time to be 9.58 seconds, isn't it? But you don't know the rate. So what you do is that this time you replace the distance with what you already know, which is 100 meters. Then rate will still maintain because you don't still know it. Then the time is also known, so you replace the time to with its known time, isn't it? Then the explanation will continue from there.
Solving for rate. So how can we do that?
You are looking for the rate.
Well, if you look at this right-hand side of the equation, I have 9.58 seconds times rate. If I were able to divide this right-hand side by 9.58 seconds, I'll just have rate on the right-hand side, and that's what I want to solve for. So you say, well, wait, why don't I just divide the right-hand side by 9.58 seconds? 9.58 seconds. Because if I did that, if the units cancel out, if we're doing dimensional analysis, don't worry too much if that word doesn't make sense to you, but the units cancel out and the 9.58 cancel out. But I can't just divide one side of an equation by a number. when we started off, this is equal to this up here. If I divide the right side by 9.58, in order for the equality to still be true, I need to divide the left side by the same thing. So I can't just divide the right side, I have to divide the left side in order for the equality to still be true. If I said one thing is equal to another thing, and I divide the other thing by something, in order for them to still be equal, I have to divide the first thing by that same amount. So I divide by...
So you see, what he was just saying is that the first time you began, he said this is equals to this. Are you getting it? So if you say 100 meters is equals to this, it means that when you are dividing this side by 9.58 seconds, for your equality to still maintain its value, you need to divide this side too by the same 9.58 seconds. Is that okay? So that was what he was just explaining. So
9.58 seconds. So on the right-hand side, and this was the whole point, these two cancel out. And then on the left-hand side, I'm left with 100 divided by 9.58, and my units are meters per second, which are the exact units that I want for rate or for speed. And so let's get the calculator out to divide 100 by 9.58. So I've got 100 meters divided by 9.58 seconds. It gives me 10. Let's see, we get about 3 significant digits here, so let's say 10.4. So this gives us 10.4. I'll write in the rate color. 10.4, and the units are meters per second. Meters per second is equal to